I'm building the most overly ambitious water-cooled coffee table you have ever seen, with features so wild you probably wouldn't even believe them. And it all started because I was worried when this little guy visits he might poke his eye out on the absurdly sharp corner of our coffee table. This spiraled into a full-blown obsession, weeks of designing and what might be the most over-the-top coffee table ever. It features a custom embedded fridge, a smart home touchscreen dashboard, RGB lights everywhere, a premium tabletop, multiple wireless charging pads, a heated and cooled drink surface, and a task light that literally rises from the surface. Now let's see if I can actually build any of this. This video was made possible by JLC CNC, more on them later. So this coffee table is going to have insane amounts of upgrades. It's going to be water cooled, it's going to rotate, it's going to have LEDs, it's going to have fridge temperature control, a bunch of other stuff, battery powered, all using these components here and with a touchscreen that runs on Home Assistant. Now the plan for power is pretty simple. I'm going to take the incoming wall power and step it down with a DC power pack. That'll feed into a slip ring, which lets the coffee table spin freely while still maintaining power. From there, it splits. One line goes to the charging the battery, and the other provides a direct connection to the system. I found this old Dell power supply, a 240 watt. We're going to modify this slightly to get all the power we need for the project. I'm disassembling everything because I have this nice fabric cord that I'm going to use instead of the black cord. It'll match nicer with my carpet, and I'll have to just splice it in and it will be good to go. For incoming power, I want it to be magnetic so I can disconnect it. So I have this 10 amp, supposedly 10 amp connector, but that's coming in the mail, so we'll see about that. Now there are these pogo things I can use, not those, but they generally are not for high current capability, or at least I won't trust it for that. I'm excited. Just got these parts in. That was ridiculous. I'm really excited though. I finally got my custom design fridge in, including some CNC machine parts for the water cooling. It took me so long to design this. This thing will have a spot to control the temperature. It'll have nice acrylic shelves, as well as a formed acrylic door. It's got some nice little hinges. Gosh, I'm so excited, and I was so apprehensive of getting this. I thought it wasn't gonna print right. This is SLA printing. I'll talk more about my sponsor later. Yeah, I'm absolutely stoked about this. Oh, jeez, ouch. Okay, so here's the deal. The MDF is gonna be used for the structure and to make everything beefier and fill it in. The plywood over there is gonna be for the carcass and for the wood slats. Now, the thing will be wrapped or sheathed in this bendy plywood here. It's very bendable. And it'll all be covered with this nice walnut veneer. Now, behind me is an acrylic panel, and that will be used for the glow, the underglow, and around the edges, there's gonna be a nice little, I'm not even sure what it's called. A little ambient light. Now up top we have Corian, which is a tabletop surface, and it's very nice and hard. That's what she said. And it should look great. So here we go. What craziness would you add to this coffee table? Most like, comment, I'll attempt to add it in the next video. So, moment of truth. We'll see if the slip ring fits. It looks like it does. Oh, it fits so nice. So I just received the magnetic connector I got from AliExpress, and it's not gonna work. The contact point is too thin, and I'm afraid it will shift around and it may cause a short circuit. It was rated for 10 amps, but I don't think that's true. And I'm also worried about the connection when hot loaded. There might be a spark. So for now, I'm pivoting to a direct connected wiring. This kind of defeats the purpose of a battery, but it is what it is. And I may revisit the magnetic connector, making a custom one in the future. So next we have this jig I printed. It should fit on just, I have to line it up perfectly with this routed channel here. MDF is known to absorb a lot of paint, so it's a good idea to prime before you paint, and prime very good before you paint too, and it makes all the difference in the world. When the coffee table is spinning around on this Lazy Susan, you would think that the wires coming in from on the power are going to cause this to tangle up while it spins. But this device called the electronic slip ring will prevent it from doing that because it actually has contacts that move around this top part. So you can spin it as many times as you want and it will not tangle. Pretty cool device. In a perfect world, we'd ditch the cord. Maybe use a wireless charger under the carpet or something. But those get hot and nowhere near the current we need. I'm not trying to start a fire, so yeah, we need the cord. Let's be honest, you've already got cables everywhere, so one more is not gonna hurt. Okay, so this thing is perfect. The paint finish is great. The bearing surface, smooth. The slip ring is working as it should. Now I'm just wondering, should I motorize this thing? I mean, it wouldn't be that hard. Maybe, For the plywood structure, I used 3/4 inch ply I had on hand and cut it out on my CNC and did some fine tuning for clearances for a loose fit. And just in time, because I got my parts in from this video's sponsor, JLC CNC. They offer a robust suite of CNC capabilities and materials. I used their CNC machining service for my fridge's cooling plate. It was easy. I chose my material and specified the surface finish and uploaded locations for my threaded holes. Not only do they have CNC machining, but also milling, turning, and also have EDM capabilities. While I was at it, I needed a robust fridge and had them print a massive SLA part using their 3D printing service as well, and it turned out incredible, far better than what I could do using my FDM printer. Ordering was easy too, whether it's CNC, 3D printing, mechatronic parts, PCBs, JLC has got you covered. And now back to the video. This fridge is going to be absolutely packed, but before we go any further, we have to see if this thing will actually cool, this Peltier device. So I hooked it up with some 12-volt power and just wanted to see what kind of temperatures I can get. And it seems like around 17 degrees, which is great. This little limit switch will control the power to the LEDs I'll have embedded into the fridge, and when it opens, it'll trigger. I made a small recess on the front of the fridge and added an access hole in the back to route and tidy up the wiring. I also cut slots to embed magnets that will hopefully hold the lid closed. For controlling the fridge, I'm using an Inkbird temperature sensor with a Peltier device. It should work as is, no relay needed. I did a dry fit just to see if everything will fit perfectly. This will also connect to a temperature probe to negotiate when cooling should happen. Now for this water cooling block, I didn't specify the surface finish, so I just had to sand this down to 1000 grit and do some expanded foam in the cracks. Now I'm using some foil-backed insulation for the sides of the fridge. I didn't have 1/2 inch thickness as I originally designed, so I jumped back on the CNC and custom cut the insulation. I know it's overkill, but it saved me a hassle of routing to the correct depth to make everything fit. I insulated all sides of the fridge with 1/2 inch polyiso sealed tight, which gives a decent thermal resistance. The weak spot is definitely the door. A single 1/4 inch sheet of acrylic leaks more than all of the insulation combined. I was hoping to get away with it, but I'll probably need to add a second layer with a 1/2 inch air gap so the Peltier isn't overwhelmed. For anyone curious, I ran the numbers to estimate the thermal load and cooling margin. Let me know in the comments if this looks on track or I'm missing something obvious, especially if I think I need to insulate somewhere more. I used RTV silicone to adhere the cooling plate before adding the Peltier device. Then tightened it down and secured it with a bracket that'll also hold the water cooling block. And finally, to finish off the fridge, I added LEDs to the pack just to really set this thing off. I picked up some plain sliced walnut from Rockler, a 4x8 sheet, and started cutting it down for the walnut niche and back panel. The back panel will hold some LEDs that will give it a nice back glow, and it will light up the Corian shelves as well. I wanted this thing to be totally overkill, so I'm adding USB ports that fully support power delivery. That means theoretically I can push up to 200 watts. So yeah, definitely future-proofing this. Corian is a new material to me. I hadn't worked with it before this. It's used on a lot of countertops and it's super easy to work with. You can route it, which I'm doing here, and also on the top in the next video. It comes in a bunch of colors and styles, and honestly, it looks pretty great. It's also gluable, and you can build it to make whatever you're working on look thicker and more high-end. And since it's sandable and routable, it's perfect for this project. Quite a bit done. We have the stationary base done, the plywood uprights, we have the walnut veneer panels, we have the Corian countertop shelves. Most importantly, we have the power coming in on the slip ring, so we can spin this as many times as we want and it's not gonna twist around on us. Now I'm working on the walnut carcass, and I'm using some bendy plywood, which is a crazy cool material I hadn't used before. But yeah, this didn't exactly go according to plan. I switched from wood glue to contact cement, which I'm not super familiar with, and well, yeah, you'll see in a minute. These projects take a ton of time. This one alone took me almost a full month just to design and refine. And that's not even including all the filming and editing I'm doing. So do me a favor, if you're into this kind of content, give a like and maybe subscribe so you don't miss part 2. Oh, also shameless plug, I do have a Patreon and I update that regularly. Okay, well, got an issue here. It's not gonna cut it. I got too hasty with the contact cement and it just didn't adhere. I think we'll just power through and try to fix it down once I cut the slats, but I may have to start over. These are threaded nuts that I'll attach to the bottom base. This is where the top section will mount to securely. Now it's just a matter of assembling everything and gluing and screwing it all together permanently. Now these 3D printed radius pieces are going to make it easy for me to route an accurate profile into the veneer facade, so the fridge can mount cleanly inside. You'll see once I get to that part, which by the way goes way better than I expected it to. To adhere the Corian pieces, I used some extremely old 2-part epoxy that sets in 5 minutes. Bit of a rush job, but it worked out pretty well. And I didn't have to go buy more epoxy, so that's a plus. Now I'm circling back to the back panel of the niche. I'm adding some addressable lights that glow from both sides of the panel, and I think it's going to look really, really nice. Now here's where it gets fun. I'm jam-packing this thing with all sorts of fun stuff, including LED lights and control circuitry, fuse boxes, and just a whole bunch of other stuff, so it's going to be awesome. I went with addressable lights that include a warm white channel, which makes it easy to mix with the cool white of the standard RGB. That way I can dial in a more accurate, natural looking household lighting color. Now I'm moving on to a really cool part of this build, which is the water cooling. I'm using a standard PC pump and I need a simple bracket to mount it. Plus an isolation damper so the coffee table doesn't vibrate when you're watching a movie or something. But before we get into the water cooling loop, we need to add some power for testing. I didn't want to dive too deep into electronics of this build, but maybe I'll cover that in part 2. Let me know if you want to see more of that. Right now I'm using what I'm going to call a cobbled together distribution circuit. It takes the 20 volts from the Dell power supply and steps it down to 12 volts, and then that separates it into the direct connection and the battery connection. Honestly, the battery is kind of just for show at this point. I really wanted the magnetic connector to work so I could disconnect it during a party or something and have it run on battery power for the night. But oh well, now it's basically an emergency backup light if the power goes out. Kind of silly, but kind of cool. This little unit will show up in part 2. It's a relay module that will eventually hook up to a heated and cooled plate on the surface of the coffee table. I'm planning to pair that with a copper mug for maximum heat transfer, and hopefully it'll cool or heat your drink in a reasonable amount of time. We'll see though. Here I am just pre-wiring things for future use. My water cooling loop essentially runs from the pump to the radiator to the heated and cooled plate, back to the fridge, and then to the pump again, and it just keeps cycling. I'm just hoping that I have enough water to keep everything cool so it runs efficiently. You'll see I've got 2 water cooling blocks, one for the refrigerator and one for the heated and cooled plate. I'll also add a flow sensor just so I can know if the coffee table's pump ever goes out. Now here's where I had to break out the big boy math to figure out the slat spacing. I'm just kidding, I just did it in CAD and followed the numbers. It came out to be 0.82 inches. I ran into a bit of an issue with the access door on the coffee table. Since there wasn't a slat right up against the back section, that curve didn't carry through and the door wouldn't sit right. So I printed these radius guides, I guess I could call it, basically shaped to match the table's outer diameter, and fixed that problem pretty good. This little area here is another 3D printed bracket that holds the fan and radiator setup together, but I needed a clean, accurate hole in the veneer wrap, so I printed another jig, and you'll see me route that in a minute. This part of the build was honestly pretty stressful. Getting the slats on and the timing of which slat needed to go on was trickier than I expected. I'll just let you watch through and just feel my suffering. The rubber cement fiasco wasn't as bad as I expected it to be. I tossed out the really bad slats, and for the ones with minor adhesion issues, I just went back and reattached them with some super glue. Surprisingly, the whole thing took me about an hour or so. Now we're at a point where I need to route out the fridge channel before adding the remaining slats. And honestly, it was just as satisfying as I imagined back when I was designing the fridge. Once every single tiny little slat was installed, I moved on to veneering with a walnut edge trim. Luckily, I found a size that fits perfectly with the width of the slat, so I didn't have to buy an expensive 2-inch band and install that. Here I'm just adding some magnets for the access panel that covers the electrical components. After that, I finish everything with some hard wax. My favorite brand, but not sponsored, but seriously, Natural One Coat is superior in my opinion. Please sponsor me. So before we move on to final assembly of this crazy build, I just want to thank everyone that's still here. Definitely consider subscribing if you haven't already, because this project is going to get even more crazy in part 2. I'm also ramping up my Patreon with updates throughout the build. Consider joining and be part of the design process and get a kind of a sneak peek as progress gets made in real time. Thanks, and here's the build. Oh, shit. There I was, realizing the pads weren't adhesive. I attached those to the stationary base to make sliding on the carpet much easier. I then mount the stationary base to the rotational base, if you could call it that, using some panhead screws. Super convenient that I added the access hole on the bottom to get them all aligned. Now, most importantly, I added the main power through the slip ring and connected it to the distribution terminal. Second to last thing, I finally installed the Peltier device onto the cold side of the aluminum plate. I used thermal paste for better heat transfer, with the mounting bracket also doubling as a passive radiator. And the very last step, arguably the most important or the best looking, is the RGB controller. Gladopto sent me their newest WLED ESP controller, and this thing's going to be awesome for the coffee table build. I'm using 2 of the 4 outputs so far, and in part 2, I'll go over more of the wiring. Setup couldn't have been easier. I'll drop a link in the description if you're curious about it. As always, thank you so much for watching. Make sure to subscribe so you don't miss part 2 of this build.